Hi guys, my name is Anika and welcome to 8th grade science with Austin. Today's topic is part 1 of the matter, properties, and change standard. This video covers the classification of matter into elements, compounds, and mixtures, as well as the organization of the periodic table. As always, our videos consist of 8 to 15 review questions. Each one is timestamped in the description box. If you get a question right, feel free to skip to the next timestamp. Otherwise, go ahead and watch the explanation after the question. If you want to review certain topics after this video, we have a links for further reference page, which is linked in the description box along with all of the questions in this video. On this page, we have a link that goes with each question, so you can dive deeper into the challenging ones. These links are great for extra review. Alright, let's get started with the first question.
With question 1. Which subatomic particle determines what element an atom is? So we're going to give you a couple seconds to do this question, and if you need extra time, you can always pause the video and play it again when you're ready to see the answer. Okay, so the answer to this question is proton. So if you got that right and you understand why that is, feel free to skip to the next timestamp and do the next question. If not, we'll be explaining why that is right now. So this is an atom. As you can see, it has 3 different subatomic particles, the red one, the blue one, and the green one. So this red one over here, these are protons, which happens to be the answer to this question. Protons have a little plus in them. That's because they have a charge of +1. Protons are positive. The blue particles, the ones that are next to the protons, these ones are known as neutrons. And they have a little 0 in them because they have 0 charge. No charge. They are neutral. The green ones over here, these are known as electrons. And they have a minus in them because they have a charge of -1. So in an atom, the protons and neutrons, the ones right here in the center, they're all in this group, and this group is known as the atom's nucleus. The number of protons in an atom's nucleus, so the number of protons in the nucleus, is known as the atomic number of an element. So that's the number of protons in the nucleus of one of the element's atoms. No two elements have the same atomic number, so every element must have a different number of protons in the nucleus. So that's how you know which element an atom is. If it has a certain number of protons, then you just have to figure out which element has that many protons in its nucleus, or which element has that many protons as its atomic number. So in this drawing right here, there are 2 protons in the nucleus. So when you look at a periodic table and you know how to find an atomic number, you'll find that helium is the element with 2 protons in its nucleus. Helium's atomic number is 2. So that's how you can determine what element an atom is. So that's why proton is the subatomic particle that determines what element an atom is. Question 2. Molecules of ice move faster or slower than molecules of water. For this question, you're picking which of the 2 words better fits the blank. So the answer to this question is slower. So the sentence is going to read, molecules of ice move slower than molecules of water. So if you got that right, go ahead and skip to the next question. Otherwise, let's look at the phases of matter and see how knowing their properties can help us answer this question. So this first diagram here is a diagram of a solid. So what do we know about the particles of the solid? Well, as you can see in the diagram, they're very close together. They also have very, very strong bonds. So because these particles are so close together and have such strong bonds, they don't move away from each other at all. They stay in the same spot. And that's what gives solids their uniform shape and size. So the shape and size of solids doesn't change. So the next model looks a little different from the first one, and that's because it is the model of a liquid. So what are the properties of the particles of liquids? Well, we know that liquids are melted solids, and when you're melting something, you add heat to it. So if we're adding heat to the particles of a solid to make it a liquid, the particles will start to move faster because when you add heat to particles, they start to move around. So liquid particles move around, so they're not like solids. However, they still have bonds. Have bonds. So they can't just go wherever they want. They're still connected to one another. So because they still have bonds, but they can move around, liquids always have the same size because they can't move away from one another, but not the same shape. They just take on the shape of their container. This last model looks a little different from the first two, and that's because it is the model of a gas. So gases have more heat than solids and liquids. So they have the most heat of all three phases of matter. And when you add this much heat to particles, they move really, really fast. So fast that they break the bonds between them. So the particles of gases have no bonds between them. They're free to move however fast they want and however far away from each other they want. So because of this, gases don't have a uniform size or shape. The size and shape of a gas can be whatever it wants to be. It's not, the particles don't hold each other together. So, how does knowing these things help us answer this question? Well, the question is asking about the molecules of ice, which is solid water, and the molecules of water. And we obviously know that water is a liquid. So, would the molecules of a solid move faster or slower than the molecules of a liquid? And the answer is going to be slower because the molecules of solids don't move at all. Question 3. You have 50 grams of a liquid and 50 grams of a gas. Which one has the higher density? I'm going to give you a couple seconds to try this out before I put the answer up. Okay, I'm going to go ahead and put the answer up. So the answer to this question is the liquid. So the first thing we have to keep in mind for this question is that density is equal to mass divided by volume. And the common units of density are grams per cubic centimeter and kilograms per cubic meter. For this question, we're going to use grams per cubic centimeter because the masses of the liquid and the gas in the question are given in grams. So if we know that the masses of a liquid and a gas are the same, how do we know which one has the larger density? So first of all, we know that the volume of the liquid will always be less than the volume of a gas of the same mass. The of the same mass part is really important. And we know this because, as we saw in the last question, gas particles are much more spread out than liquid particles, which means it covers much more volume. So if we know that the volume of a liquid is less than the volume of a gas of the same mass, we can just plug in some random values to find out which density is higher. So let's say that the volume of the liquid, so I'm going to say volume liquid, is 50 cubic centimeters. And the volume of a gas is 100 cubic centimeters. So these are just some random values that we plugged in. All that's important is that the volume of the liquid is less than the volume of the gas because they're the same mass and gas particles are more spread out. So if we take these values and then we plug them into the density formula, so let's do it for the liquid first. So density is equal to the 50 grams over the 50 cubic centimeters. we're going to get 1 gram per cubic centimeter. And let's do it for gas. Density is equal to 50 grams over 100 cubic centimeters, which is 0.5 grams per cubic centimeters. So as you can see, when a liquid and a gas have the same mass, the liquid has the higher density. Question 4. Identify the following as either an element, compound, homogeneous mixture, or heterogeneous mixture. Sugar, calcium, water, air, carbon dioxide, salad, brass, M&M's packet, and gold. You're definitely going to need to pause the video for this one, so I'm just going to give you like 2 seconds to pause the video. Okay, assuming that you've replayed the video, here is the answer. Sugar is a compound, calcium is an element, water is a compound, air is a homogeneous mixture, carbon dioxide is a compound, salad is a heterogeneous mixture, brass is a homogeneous mixture, and M&M's packet is a heterogeneous mixture, and gold is an element. So if you need to take some time to pause and check over that slowly, go ahead and do so. Otherwise, we're going to go right into looking into these classifications. So the first type of classification is element. So an element is a pure substance that is made up of only one kind of atom. Of only one kind of atom. So this is very important. If the atom is different, it's a different element. Elements cannot be broken down into simpler substances. And as we learned in one of the first few questions, they're dependent on the number of protons in an atom. So the number of protons in an atom determines what element it is. All matter is made up of elements. That's very important. All matter. There is no exceptions. Made up of elements. The elements in this question were calcium and gold because they cannot be broken down into anything else. All they are calcium atoms and gold atoms. So calcium, gold. The next kind of classification in this question were compounds. So, back. Compounds. So, like all matter, compounds are made up of elements. So these are pure substances made up of 2 or more elements chemically combined in a defined ratio. So this means that every time you see the same compound, there's going to be the same amount of each element that makes it up in the compound. Ratio. So compounds do not have the same properties as the elements that make them up. Once 2 or more elements combine to make a compound, that compound is its own substance. It does not have the properties of the elements that makes it up. Compounds have chemical formulas to show how many atoms of each element are in one molecule of the compound. So that's what we mean here by the defined ratio. In every molecule of the same compound, there will be the same number of atoms of each element. So the compounds in this question were sugar, which has a chemical formula of C12H22O11, water, and hopefully you've heard the chemical formula for this, H2O, and carbon dioxide, which you might even know by its more common name, CO2, which is its chemical formula. Okay, so the next type of classification we're going to talk about are mixtures. So there are 2 types of mixtures in this question, but first we should know what a mixture is. So mixtures are combinations of 2 or more substances So it's important to note that we said substances and not elements. So a substance can be anything. Two or more substances combined physically. So compounds are two or more elements combined chemically. So you need a chemical reaction to break it up into its elements. You don't need a chemical reaction to break apart a mixture. Each substance in a mixture keeps its own properties, and then you can separate them without a chemical reaction. So those are the big things about a mixture. So the two types of mixtures are homogeneous and heterogeneous. So we're going to look at homogeneous first. So in a homogeneous mixture, it has a uniform composition. So that's just like a compound, where it has the same ratio of all of its elements no matter what sample you take of the compound. So, no matter what sample you take of the same homogeneous mixture, it'll always have the same ratio of the substances in it. A homogeneous mixture also has specific properties as a whole. The different parts cannot be seen. So, different parts cannot be seen. So in this question, the homogeneous mixtures we have are air, which you may, if you studied the earth science before, you may know that air, no matter what sample you take of air, is always made up of 78% nitrogen, 21% oxygen, 1% argon, and then small percents of those trace gases. So you know that it's always the same ratio of those gases. So that's what makes air a homogeneous mixture. And the other one in this question is brass, which is usually made up of copper and zinc. So it'll always be the same amount of copper and zinc in any piece of brass. It's important to know that mixtures can also be solids. So brass is a mixture even though it's a solid, and that's because it's a combination of other metals. Okay, so the next type of mixture is a heterogeneous mixture. These are long words. A heterogeneous mixture is one where the different parts of a mixture can be seen. So, different parts of the mixture can be seen. And it does not have a uniform composition. So, just because you take one sample of a heterogeneous mixture and it has this much of one substance and this much of another substance, that doesn't mean if you take another sample of the same mixture, it'll have the same amounts of each substance. So, not a uniform composition. So the heterogeneous mixtures in this question are a salad. So in a salad, even if you take two spoons, let's say, of the same salad, the salad may have lettuce, tomatoes, and spinach, for example. The two spoons are not going to have the exact same amounts of lettuce, tomatoes, and spinach, and that's why it's a heterogeneous mixture and not a homogeneous. Also, you can see the different parts. You can see that there are lettuce, there are tomatoes, there is lettuce, and there is spinach. You can see the different parts, and that's what makes it a heterogeneous. The other one is an M&M's packet. So just like that, M and M's packet, just like a salad. In an M&M's packet, you can see the different colored M&Ms. Each of the different ones can be seen. And just because you take the same M&M's packet, it doesn't mean that it'll have the same number of each color of M&M. So that's what makes it a heterogeneous mixture. Okay, moving on to question 5. Carbon 13 is a blank of carbon with blank neutrons. I'll give you a couple seconds before I show the answer. Okay, the answer to this question is isotope and 7. So carbon 13 is an isotope of carbon with 7 neutrons. So the first thing we have to do is ask, what is an isotope? Isotopes are when two atoms have the same number of protons, which, as we know from earlier questions, makes them the same element. So they're the same element, two atoms of the same element, but with different numbers of neutrons. When an element is written like this one up here, so it says carbon 13, right? So we have the element name and then its mass number. When it's written like this with the name and the mass number, that's how we know that it's an isotope. The mass number of an element is the sum of its protons and neutrons. So if we know that carbon 13 is an isotope and we have its mass number, how do we find the number of neutrons? Well, the number of protons in carbon is also known as an element's atomic number. And by looking at the periodic table, we can find that carbon's atomic number is 6, and we'll learn how to find that in the next question. So carbon's atomic number is 6, so it has 6 protons. So if its mass number is 13 and it has 6 protons, then it'll have 7 neutrons. So that's how we know that carbon 13 is an isotope of carbon with 7 neutrons. Question 6. Using the periodic table, find the following properties of carbon: symbol, atomic number, atomic mass, and number of valence electrons. You're going to need to pause the video for this one. Assuming you've paused and replayed the video, I'm going to go ahead and show the answer now. So the answers to this question are: the symbol of carbon is C, its atomic number is 6, its atomic mass is 12.011, and its number of valence electrons is 4. So first, let's start with carbon's block on the periodic table and see what information we can get from that. So this 6 in the top left corner is carbon's atomic number, which, as we know, is the number of protons in an element's atom. This is the most important thing in terms of determining an element's position on the table, because atomic number increases from left to right and top to bottom on the periodic table. Next, we have this huge C in the center, and this is carbon's symbol. And that's the letter that represents it in chemical formulas. And then obviously, a lot of periodic tables do have the element name in the box, some don't. And then we have this number in the top right, which is carbon's atomic mass. The atomic mass is the average of all the mass numbers of all the isotopes of an element based on how common each of those isotopes are. So if you want to know quickly how to know which one is atomic number and which one is atomic mass is always going to be a whole number, and atomic mass usually has a decimal near it. So the next thing we need to do is find the number of valence electrons in carbon. So finding the number of valence electrons is slightly more challenging. We need to look at carbon's position on the periodic table. Carbon is in group 14 of the periodic table, which is right there. Groups are the vertical columns on the periodic table. So this is an example of a group. And there are 18 of them in total. All the elements in a group have the same number of valence electrons. Valence electrons are the electrons in the outer shell of an atom. This is very important because it determines how atoms react with other atoms. If two elements have the same number of valence electrons, they react similarly. Therefore, all the elements in a group are chemically similar. How do we find the number of valence electrons just by looking at the periodic table? So if we look at this periodic table, there's a section in the middle that's boxed, and these are groups 3 to 12, and they're known as the transition metals. You can't find the valence electrons for these groups just by looking at the table. But if you ignore groups 3 to 12 and you label the other groups 1 through 8, so this being 1, 2, and the group which carbon is in, group 14, is here, and it is labeled group 4 if you ignore groups 3 to 12. So if you ignore these groups and label these 1 through 8, you can find the number of valence electrons based on the number that's above the group. So in group 14, it's labeled 4, which means any element in group 14 has 4 valence electrons. Question 7. In this chemical formula, how many atoms are there of each element? And this is NaHCO3, which is the chemical formula of baking soda. The answer is 1 sodium, 1 hydrogen, 1 carbon, and 3 oxygen. So, first thing we need to do is identify what elements are in this compound. So, you can use the symbols and then look them up on a periodic table. So, something that might be a bit confusing is whether Na are two separate symbols, N and A, or they're together. And we know they're together because the A is lowercase. So, a symbol always starts with an uppercase letter. So, if it's just a single letter symbol, it'll be uppercase. So, Na is a symbol, H is a symbol, C is a symbol, and O is a symbol. So when you look this up on the periodic table, right now I'll just tell you, but when you do look it up, Na is sodium, hydrogen is H. From our last few questions, carbon is C, and O is oxygen. So once you've found the symbols, so we've figured out all the symbols, you have to look at the subscripts, which are the small numbers on the right side of the symbols, which is this right here. This is an example of the subscript. So in baking soda, there's only one subscript, which is the 3 for oxygen. A subscript tells you how many atoms of that element would be in one molecule of the compound. So there are 3 atoms of oxygen in one baking soda molecule. When elements don't have subscripts, like sodium, hydrogen, and carbon, there is only one atom of each in the compound. Okay, moving on to question 8. You discover a new element, element X. You decide to test what element X can react to and compare it to other elements. The results are in the table below. Based on this, what group of the periodic table would you put element X in? Does this mean that it's a metal, nonmetal, or metalloid? You will need the periodic table, and you're probably going to need to pause the video. Okay, hopefully by now you've paused the video and solved the question, and you're back for the answer. So the answer to this question is group 17 and non-metal. So how do we find this? First, we need to find what group element X is in. We know that all the elements in a group are chemically similar. This means that their reactivities and what they react to are similar. Based on the table, element X is most similar to fluorine because both are very reactive and commonly react with group 1 elements. This means that element X and fluorine would most likely be in the same group. By looking at the periodic table, we can find that fluorine is in group 17, which is why element X is also in group 17. Now, how can we find whether element X is a metal, nonmetal, or metalloid? Not surprisingly, we can find this on the periodic table too. Metals, nonmetals, and metalloids each have their own spot on the table. Metals are on the left, nonmetals are on the right, and they are split by a staircase of metalloids. So here the metals are in blue, the metalloids are in orange, and the nonmetals are in pink. So based on the arrangement of metals, nonmetals, and metalloids in the table, we can look for group 17, which is the group we found for element X. Group 17 is on the right, so it's a nonmetal. Therefore, element X is a nonmetal, just like fluorine, which it is similar to. Question 9. The following tables shows some elements from one period of the periodic table. It also gives you their atomic numbers and atomic masses. Which of the following could be the atomic mass of bismuth? A 137.33, B 178.49, C 190.23, or D 208.98. Go ahead and take a couple seconds to solve this problem or pause the video if you need some more time. Okay, I'm going to go ahead and put the answer up. The answer is D 208.98. So in this problem, the numbers look really complicated, but we don't actually have to understand any of them. What we're looking for is a pattern. So the first thing to note in this problem is that all the elements come from one period. Periods are the left to right rows of the periodic table. So this one right here at the bottom, this is a period. Elements in one period aren't very similar. They have the same number of electron shells, but that doesn't mean anything in terms of reactivity. What's important to note is that in both periods and groups on the periodic table, there are patterns from left to right and top to bottom. The most common pattern is that atomic number, aka the number of protons, increases as we go from left to right across a period or top to bottom in a group. Because of this, we know that the elements in the table are in a left to right order because their atomic number is increasing. So it goes from 55 all the way to 86. So the elements in the table are in a left to right order. There are many other left to right and top to bottom patterns in periods and groups. Here, the question is asking about atomic mass. If you look at the atomic masses of the elements in the table, they increase as we go from left to right. This is another pattern. Based on this, you know that the atomic mass of bismuth is less than that of radon, but more than that of osmium, because as it goes left to right, it increases. The only option that fits that criteria is D. Question 10. A bromine ion has a charge of -2. How many electrons does it have? You might need to check out bromine on the periodic table. Okay, so the answer to this question is 37 electrons. So the first thing we have to ask is, what is an ion? So an ion is an atom that it gains or loses electrons, which gives it a positive or negative charge. In a normal atom, the number of protons equals the number of electrons, the number of electrons, giving it a neutral charge or a charge of 0 because protons are positive and electrons are negative. So if the number of protons equals the number of electrons, there's going to be a charge of 0. But in an ion, the number of protons does not equal the number of electrons because the ion has gained or lost electrons. So in a normal bromine atom, there are 35 protons, and we know this from bromine's atomic number, which we can find on the periodic table. So if a normal bromine atom has 35 protons, it also has 35 electrons. But because this bromine atom has a charge of -2, it would need to gain 2 electrons because electrons are the ones with a negative charge. So if it normally has 35 electrons and then it gains 2 electrons, that's how we get to 37 electrons. Question 11. Which of the following elements is the least reactive? A. Hydrogen, B. Iron, C. Neon, D. Boron. You can use the periodic table for this one. Okay, so the answer to this question is C. Neon. So neon is the least reactive because it is a noble gas. There are a few groups you should memorize on the periodic table, and group 18, noble gases, is one of them. So I'm going to put up a list of groups that you should memorize. So the first one is alkali metals, which is group 1, which are extremely reactive metals because they only have one valence electron, which is easy to lose. Number 2 is alkaline earth metals, which happens to be group 2, which are very, very reactive metals, but not as reactive as alkaline metals. The third set of groups that you should memorize is transition metals. You can't tell how many valence electrons are in transition metals just by looking at the periodic table, because transition metals have valence electrons in both their outer shell and their second to outer shell. The fourth group you should memorize are halogens, which is group 17. These are so reactive that they are the most reactive nonmetals. And the last group that you should memorize is noble gases, which is group 18. Noble gases have a full outer shell of electrons. This makes them the most stable elements on the periodic table. Because they are so stable, they have no need to react with other elements and rarely do. They are the least reactive elements on the periodic table. So because this question asks about least reactive, you need to look to noble gases first. When you look on group 18 of the periodic table, which is the noble gases, you would have found that neon is one of the noble gases and therefore is the least reactive of the options. Question 12. You discover a new element, element Y. Element Y is a gas. It's also a very good insulator. Is element Y a metal, nonmetal, or metalloid? Okay, so the answer to this question is nonmetal. So you should know some basic properties of metals, nonmetals, and metalloids, which will help you classify them as in this problem. So first up is metals. So metals are the most common type of element. And we saw that when we were looking at the periodic table, how metals made up most of the periodic table. They are typically solid, although there are a few liquid metals. They're usually shiny. They are malleable. Malleable means that they can be bent into different shapes. They are ductile, which means they can be made into wires, which makes sense because metals are what makes up wires. And they are good conductors, which again goes with wires because if wires are made up of metal, then metal needs to be able to conduct heat and electricity really well. Next up is nonmetals. So nonmetals have properties opposite of metals, which might have been given away by the name. They are typically dull, brittle, which means easy to break, and insulators, so they cannot conduct heat and electricity well. Many nonmetals are gases. The last category is metalloids. Oh, where did the mouse go? Metalloids. So metalloids have properties of both metals and nonmetals, which is what makes them so special. They are the rarest of these three, so there are less metalloids than metals and nonmetals. They are often semiconductors because they can both conduct heat and electricity, but also insulate it. And semiconductors are really important in technology. They can look like metals, but be completely brittle. Some examples of metalloids are boron, selenium, and silicon. So based on these properties, how do we know what element Y is? Well, it says that element Y is a gas, which should automatically tell us that it's most likely a nonmetal. And then to prove that, it also says it's also a very good insulator, and nonmetals are very good insulators. So element Y is a nonmetal.
I hope that these questions were a good review of these substandards. Like I said at the beginning of the video, make sure to check out our links for further reference page for more practice with these topics. If this video was helpful to you, please like, share, and subscribe. Thank you for watching, and I hope to see you in part 2 of this video.